Hello, my dear students. In continuation of our mark scoring videos for senior intermediate, we are going to discuss two essay type questions. That means two 8 marks questions of first chapter, that is waves or wave motion. And these two questions are very important. You may get both these questions in the exam. There is a probability of getting these two questions as the first two questions under essay type questions category. Okay. So I am going to discuss two 8 marks questions. These are very important. Let me read the questions first. Explain the formation of stationary waves in an air column enclosed in an open pipe. Derive the equations for the frequencies of the harmonics produced. So here you have to remember two terms. I will explain them. One is stationary waves and the second one is harmonics. Right. What is the second question? The second question is, how are stationary waves formed? So even also same thing is repeated. How are stationary waves are formed? How are stationary waves formed in a closed pipe or in closed pipes? So in the previous one we had a open pipe. See, open pipe. I am going to explain step by step so that you can remember. There is a most of the students, they will be confused between these two. If question is asked related to open pipe, they start writing the answer for closed pipe and other way around. Is this clear? Right. So second question, how are stationary waves formed in closed pipes? Explain the various modes of vibration. Remember these words. I will be explaining various modes of vibrations and relations for their frequencies. Here frequencies are nothing but harmonics. Is this clear? And I'll be dealing one problem based on these. A closed argon pipe 70 centimeter. Remember argon pipe. I will be explaining all these things. These are the things we are supposed to know before we answer these three questions. Argon pipe of 70 centimeter length, if velocity of sound is 331 meter per second, what is the fundamental frequency? So another term is fundamental frequency of vibration of the air column. One more term is air column. So I will be dealing all this, right? So the first term I am interested in explaining is stationary wave. Stationary waves are also called as standing waves. The name stationary means, the word stationary means at rest. A wave is something that keeps on moving. Then how can it be at rest? That is my first question. It's not a wave which is at rest. If something is at rest, it cannot be a wave. So what do you mean by a stationary wave? Almost all waves are called as progressive waves. Progressive means going forward. It's going in one direction. That is called as a progressive wave. Any wave is a progressive wave. Once it is produced, it keeps on moving. So it is a progressive wave. I take such two waves. This is wave 1. I will take another wave 2. Two identical waves. And these two identical waves are going in opposite directions. This is wave 1 and the other one is coming from the other direction. This is wave 2. They are identical, similar. Identical, similar means their frequencies are same, their amplitudes are same, their wavelengths are same, their speeds are same. So all the characteristics are same. Right? They are moving in the opposite direction. One more thing is, they are moving through the same space. This is the area in which they are moving. It is not like this. One wave is going in this way and another wave is going in this way. They are not going to meet each other. Then they can't form a stationary wave. When such waves are moving in opposite directions, then they overlap on each other. They undergo interference. So one goes into the other. Then you will get a wave pattern like this. So this is called as a stationary wave. The best way to get a stationary wave is, the best way to get a stationary wave is you fix a thin wire between two fixed walls or fixed points. This is called a stretched wire or a string. Just you pluck it in the middle, then one wave is produced and gets reflected, another wave is produced and gets reflected at the other end. After the reflection, they meet. So this is the ideal way to produce a stationary wave pattern. So on this wire, on this string, you will see these loops. You will see these loops. The points where the string is not at all vibrating, the points where the string is not at all vibrating are called nodes. This is a node, this is a node, this is a node. The points where the string is vibrating with maximum amplitude is called antinode. Is it clear? So you have one more here, one more here, one more here. So this is a stationary wave. Why it is called as a stationary wave? This wave is confined between two fixed boundaries. It's not going beyond these two limits. That is the reason why it is called as a stationary wave. It doesn't mean that the wave that is at rest. Is this clear? Right. So stationary waves can be formed on stretched strings. Stationary waves can be formed in air columns. So air column generally found in a tube or a pipe. So this pipe encloses some air. So this is called as an air column. And these pipes are of two types. The first one is called open pipe, and this is called as closed pipe. For a open pipe, both the ends are open. For a closed pipe, one end is closed, the other end is open. Is this clear? So when I vibrate the air with the help of a tuning fork, now this air column will also vibrate. Is this clear? So this is vibrating air column. Now the another term is organ pipe. Organ pipe is nothing but these two type of pipes. Generally these pipes are found in musical instruments like tabla, mrudangam and all. So stringed instruments are like guitar, veena, violin. Is this clear? Right. So one more thing. The distance between two successive notes is equal to lambda by 2. The distance between two successive antinodes is also lambda by 2. Now tell me, the distance between a node and its immediate next antinode is lambda by 4. This is lambda by 2. So this is lambda by 4. Is this clear? You are supposed to know all these things. Then only you can answer. Now, one more thing. Modes of vibration. What do you mean by modes of vibration? Ways of vibration. Mode means a way. So this is a string fixed between the two fixed points. I can vibrate it such that it vibrates with a single loop. So the frequency will be F1. I can make the string of the veena, I can make it to vibrate such that two loops are formed. The frequency, let us say F2. This frequency will be different from this frequency. The same wire, but the way of vibration is different. So these are called modes of vibration. So modes of vibrations will have different frequencies. And one more thing, you have to remember another property called resonance. So in open pipe or in closed pipe, each mode of vibration indicates resonance. So you might have done in your laboratory resonating air column method to determine the speed of the sound in air. Is this clear? Right. So you must know about resonance. Resonance is the condition where the natural frequency of the object is equal to the frequency of the periodic force that is being applied on the object. In that situation, that object vibrates with maximum amplitude, and that phenomenon is called as uh, resonance, right? So explain the formation of stationary waves in an air column enclosed in an open pipe. Derive the equation for the frequencies of the harmonics. So one more term, harmonics, I have to explain. That I will be explaining in the middle of our answer, right? So explain the formation of stationary waves in an air column of enclosed in an open pipe. So just now I told you this is an open pipe. So I am taking an open pipe of length L. Let us say this is the length L. So I am vibrating the air column enclosed in this, within this pipe with the help of a tuning fork. Imagine this is the tuning fork. I may not be good at drawing the diagrams, right? So in the case of pipes, you should remember one thing. If the end is closed, the air here cannot vibrate. It is not that much free to vibrate vigorously. So at this end, definitely you will get a node. At open end, the air molecules are free. They have a lot of freedom to vibrate. So definitely you will be getting antinode. So at open ends, antinode. At closed ends, nodes. This is the condition, right? So I take this pipe of length L. This is called the argon pipe, that is open pipe. The minimum condition is at the open ends I should get a antinode. So possible mode of vibration is this one. This is the possible minimum. What do you call the necessary and sufficient condition is I should have two antinodes at both the ends. Now, this is antinode and this is node and this is antinode. So just now I told you the distance between antinode and node is lambda by 4 and this is lambda by 4. This is the first mode of vibration. So which produces minimum frequency, the first frequency. The first frequency is called as fundamental frequency. And it is also called as first harmonic. Harmonic is nothing but frequency. The integer multiple of first frequency, that is fundamental frequency, is called the next harmonic. They are called harmonics. Harmonics are nothing but the integer multiples of fundamental frequencies. Is this clear? Right. Now length can be written as the sum of lambda by 4 plus lambda by 4. So this will become lambda by 2. Is this clear? So from this I can write lambda is equal to 2L. You should know the formula, that is V is equal to N lambda. This is the relationship among the speed of the wave, frequency of the wave, wavelength of the wave. So from this I can write N is equal to V over lambda. Since it is my first frequency, I will put it as N1. So N1 is equal to V by lambda. So this will be V by 2L. So this is my first equation. This is the equation number 1. So this is called as fundamental frequency. Is this clear? Is this clear? This is also called as first harmonic. Now take the same open pipe of same length. Now go for the next mode of vibration. The minimum condition is you should get a antinode at the two open ends. So these are the antinodes. So the possibility is like this. Is this clear? So this is the second mode of vibration. Now from here to here, this is lambda by 4. From here to here, this is node and this is anti-node. So, 1 more lambda by 4. So, lambda by 4 and lambda by 4. Now, length of the pipe L will be 4 times of lambda by 4. So, 4 times of lambda by 4 is nothing but lambda. So, lambda is nothing but the length. Now, I write the second frequency, that is N2. N2 is equal to V by lambda. So, this is simply V by L. It can be written as 2 times of V by 2L. So, this is called as second harmonic. So, second harmonic is twice the first harmonic. Is this clear? Right. Now, we have to draw 3 modes of vibration. So, this is the third one. Right. So, you have to insert one loop here, you have to insert 2 loops. Don't concentrate on drawing, the concept is important, right. So, from here to here, this is anti-node and node. This is anti-node and node, anti-node and node. So, from here to here, 1 lambda by 4. This is 2 lambda, 3 lambda by 4, 4 lambda by 4. So, once again, let me check. So, lambda by 4, lambda by 4, lambda by 4 from here to here. From here, better to draw like this. So, 1 lambda by 4, 2 lambda by 4, 3 lambda by 4, 4 lambda by 4, 5 lambda by 4 and 6 lambda by 4 up to here 6. So, straight away you can write L is equal to 6 times of lambda by 4. Is this clear? Right. So, this will be 2 to the 3 3. This is 3 lambda by 2. Now, I want lambda. So, lambda is 2L by 3. Now, substitute in this formula. Now, I write it as N3. So, N3 is equal to V by 2L by 3. Then, this will become 3V by 2L. So, this is 3 times of fundamental frequency. So, I can write N3 is 3N1. Now, in the question, derive the equations for the frequencies. How many frequencies you have to derive? Only 3. Derive the equations for the frequencies of the harmonics produced. So, only first 3 harmonics. Now, what is the conclusion that you can draw from these 3 derivations? From these 3 derivations, you can write the ratio of, you can continue further, the ratio of harmonics in the case of open pipe is N1 is to N2 is to N3 and so on will be equal to, this is fundamental frequency V by 2L, this is 2 times of V by 2L, this is 3 times, next one will be 4 times. So, simply straight away you can write 1 is to 2 is to 3 is to 4 and so on. If you write this much, you will be getting 8 marks. So, no need to write anything, no need to write no explanation. As I dealt with the harmonics and what do you call nodes and antinodes, no need to write anything. Just draw the diagrams, do the derivations, you will be getting 8 marks. Is this clear? So, that is the first diagram, second diagram, third diagram, write the conclusion. All the harmonics are present. If you go into the next question, only few harmonics are present and few are missing. That we will be dealing in the next. Now, how are stationary waves are formed in closed pipes? If you want to, you can write 1 or 2 lines. Vibrate the air column with the help of a tuning fork. You will get a reflection. Now, I have a question. Now, one wave falls on the closed end and gets reflected, and these two will combine, they give stationary wave. Now what about open pipe? One wave is coming like this. There is no reflection, no? How do you get the stationary wave? You will get the stationary wave because of the variation of densities of the air present inside and air present outside. This is the reflection at the resident, and this is the reflection of a wave at the free end. Now, one more question, not for answering this 8 marks question, not for that purpose. The another question is, in air we will get longitudinal waves, that we know. But here I am drawing a transverse wave, no? Transverse waves can be formed on stretched strings, that I know and you also know. But in air we are supposed to draw longitudinal waves. Longitudinal waves consisting of compressions and rarefaction. Remember, a longitudinal wave cannot be depicted in this way. Longitudinal wave cannot be depicted. So it is better to draw transverse wave. But the variation of pressure is indicated in this transverse wave. So this diagram is not transverse diagram which I drew just now or which I am going to draw. This is called as a pressure wave, not a transverse wave. Is this clear? Right. Now let us take a closed pipe of length L. This is the first diagram. So at closed end I should get a node. So basic condition is this only. So I will get a node like this. So this is node and this is antinode. So length is L. So the distance between node and antinode, successive node and antinode is lambda by 4. So lambda is equal to 4L, simple. So by using the formula V is equal to n lambda, so for frequency I can write n is equal to V by lambda. So substitute 4L, so the first one you will get n1 is equal to V by 4L. So this is called fundamental frequency. Now second diagram of length L. So condition is you should have antinode. So you should insert one loop here. Here antinode. So from here to here lambda by 4. So this can be divided into two parts. So this is lambda by 4 and this is lambda by 4. Is this clear? Right. So L is equal to 3 lambda by 4. So lambda is equal to 4L by 3. Now I want next frequency. Let us write n is equal to V by lambda. So this is V by lambda is 4L by 3. So this 3 comes into the numerator. So this is 3 times of fundamental frequency. So 3 times means the second one is missing. That is the reason why this is written as N3, not N2. So this is called as third harmonic. Second harmonic is missing. Is this clear? Now another diagram. So here you should have a node. Here you should have antinode. So you have to increase the number of loops. Is this clear? Right. Like this. So from here to here lambda by 4, lambda by 4, lambda by 4, lambda by 4, lambda by 4. 1, 2, 3, 4, 5. So L is 5 times of lambda, 5 lambda by 4. Lambda is 4L by 5. Is it clear? So N5, we are going to get the fifth harmonic, fourth one will be missing. So N5 is equal to V by 4L by 5, then 5 comes into the numerator. So N5 is 5 times of N1. So obtain relation for their frequencies. Relation is nothing but writing the ratios N1 is to N3 is to N5 and so on. If you continue like this, you will be getting ratio like 1 is to 3 is to 5. Next one will be 7, 9. So only odd frequencies or odd harmonics are existing, even harmonics are missing. If you write this, that is enough. Is this clear? Right. This is about closed pipe. Out of these two questions, you will be getting either one or you may get two. Because in the model paper given by the Board of Intermediate Education, the first two essay type questions are given from the first chapter only. Is this clear? Right. If you get these two questions in the exam by chance or by luck, you will be fortunate that you will score 60. Is this clear? Now, I will be dealing one small problem. The problem may vary, but if you remember for harmonics of closed and open pipes, you can do any problem. A closed organ pipe of length 70 centimeter is sounded. If the velocity of sound is 331 meter per second, what is the fundamental frequency of vibration of the air column? A closed organ pipe. So this is the closed pipe. Right. Length is 70 centimeter. So remember, so L is equal to 70 into 10 power minus 2 meter. So this is 0.7 meter. This is length. First one is length. Second one is closed pipe. Okay. If the velocity of sound, so V is supplied, he only gave, that is 331 meter per second. That is speed of the sound. What is the fundamental frequency? Fundamental frequency, even if you don't remember also, you can do it. So antinode node, L is equal to lambda by 4, lambda is equal to 4L, V is equal to n lambda, n is equal to V by lambda, V by 4L. That's all. No need to remember. You can do it within few seconds. That is the fundamental frequency, what we called as first harmonic or N1. So the formula is n is equal to V by 4L. So V is around 330, 4L is 4 into 0.7. Is this clear? So you can solve it. So whatever the answer you will be getting, you have to write it in heads. Is this clear? If you want, I can do, but you can do. It's very easy. Is it clear? Right. So this is one numerical problem which I tried to answer. If you write the formula, you will be given 1 mark. If you write the answer, final step, you will be given 1 more mark. Most probably, this problem will be carrying only 2 marks questions. In another video, we will be dealing few more questions. Thank you.